Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for your upcoming test on simultaneous equations. So when I speak of simultaneous equations, I'm talking about situations like this. You will get two equations, each with two pronumerals or two variables. So this equation here has infinitely many solutions. This equation has infinitely many solutions, but it turns out that there is exactly one solution of this equation that is also a solution of this equation. And that's what we're trying to find. We're trying to find a solution to this equation that is also a solution to this equation. We're trying to find a solution, so a value for x and y, that solves this equation and this equation at the same time. That's what simultaneous means, at the same time. So we went through a few different methods of solving simultaneous equations: graphical, substitution, and elimination. I'll go through each of these as well as some worded problems. So let's start with the graphical method. So when you're using the graphical method, you have your two simultaneous equations here and you graph each of them. The solution to these two equations, the simultaneous solution, is simply the point of intersection of this line and this line. So I'm just going to graph this line, then graph this line. So to graph this line here, because the equation's not in the form y equals, I'll use x-y-intercept method. So I'll start by finding the y-intercept. So to find the y-intercept, you let x equal 0. So you have your equation x minus 2y equals 2. So we're going to change x to 0, so it just disappears. I've got negative 2y equals 2, y equals negative 1, just dividing each side by negative 2. So the y-intercept's negative 1, that means the line goes through this point here. So to find the x-intercept, you just let y equal 0. So if I have x minus 2y equals 2, the y just disappears, I'm left with x equals 2. So the x-intercept of this line is here. So when you have your 2 points, you simply join them up. So now we're going to graph y equals x minus 3. So when the equation of a line is in the form y equals, use gradient intercept method. Note this is y equals 1x minus 3 because x and 1x are literally the same thing. So here the gradient's 1, the y-intercept's negative 3. So I'm going to mark my y-intercept down here at negative 3. Now a gradient of 1 means you go 1 to the right and up 1. So now that I have my 2 points, I simply join them up. So here is my line y equals x minus 3. So the point they intersect, the point they hit here, is actually at 4, 1. X equals 4, y equals 1. That is the simultaneous solution to these equations. If you substitute x for 4 and y for 1 in both equations, you get a true statement in each case. So the graphical method does take a bit of time, and one thing that's annoying about it is that you have to be really accurate. So you'll get a Cartesian plane in the test, but just be aware you have to be really accurate when you draw the lines so you can see their points of intersection. All right, let's now move on to the substitution method. So for the substitution method, you substitute one equation into the other. The one you substitute is whichever one has x by itself or y by itself. So for these equations here, because the first equation is y by itself, I'm going to substitute this equation into the second equation. So how do I do that? Well, my second equation is 2x minus 3y equals 10. So what we're going to do, because y equals x minus 4, we're going to replace y. Everywhere I see a y, replace it with x minus 4. Now I need to use brackets here because I need to times 3 by the whole thing. So this here is y, 2x minus 3, y equals 10. So now we know how to solve this equation. We are going to expand the brackets. Make sure you know negative times a negative gives a positive. Now we'll collect like terms. So 2x minus 3x is just negative x. So I've got negative x plus 12 equals 10. I'm going to subtract 12 from both sides. Now, if negative x equals negative 2, x is equal to positive 2. I can change the sign of this side as long as I change the sign of that side. What you do to one side of the equation, you must do to the other. So x equals 2. Now, we're not done because we also need to find the value here of y. So x is 2, y is just 2 minus 4, which is negative 2. And we usually write our solution as a point. X first, y second. So the solution is 2, negative 2, because if I substitute x for 2, y for negative 2 into both of these equations, it solves both equations at the same time. If I were to graph this line and graph this line, they would intersect at 2, negative 2. All right, let's now look at the elimination method. So to use the elimination method, we eliminate either the x's or the y's from both equations. So how do you actually do that? Well, you end up either adding or subtracting together the equations. The idea is if we get rid of the x's or the y's, we reduce it to one equation with one pronumeral, and we know how to solve those really easily. So which one do you eliminate? Do you eliminate x's or y's? Well, you need to eliminate whichever has the same coefficient in both equations. So if the x's have the same coefficient, you eliminate them. If the y's have the same coefficient, you eliminate them. So you need to eliminate them by adding or subtracting the equations. So if the pronumeral has the same coefficient and same sign, you subtract the equations. And if the pronumeral has the same coefficient in both equations but a different sign, you add them together. So sometimes you will have a case where neither pronumeral has the same coefficient in both equations. In that case, you'll need to multiply one or both equations first. Okay, these steps sound tricky, but hopefully they'll become clearer after some examples. So let's look at these simultaneous equations here. So here, the y has the same number in front, 5, in both cases. However, in one of them it's a plus and one it's a minus. So because they have different signs, we add together the two equations. We're going to add this equation and this equation to eliminate y. So all we need to do is just add them one by one. So 2x plus 8x is 10x. So 5y plus negative 5y is 0. They cancel out. That's why we did this. Negative 1 plus 71 gives us positive 70. So now we've got a really easy equation to solve. 10x equals 70, so x equals 7. So now we need to find y. We need to substitute this back into one of the equations. Either equation doesn't matter. So I'll just substitute it into the first one. So we've got 2x, or 2 times 7, plus 5y equals minus 1. So subtract 14 from both sides, because 2 times 7 is 14, and divide each side by 5. So the solution here is 7, negative 3. If I substitute x for 7, y for negative 3, it will make this equation true, and at the same time, it will make this equation true. All right, let's look at this equation here. So here in our simultaneous equations, neither the x nor the y has the same coefficient in both equations. So what we need to do is multiply one or both equations so they do have the same coefficient. So if I multiply this equation here by 9 and this second equation by 2, the x's will then have the same coefficient, because 9 times 2 and 2 times 9 is 18. So if I multiply this top equation by 9, I need to multiply everything by 9. So I need to multiply 2x by 9, I need to multiply negative 9y by 9, and I need to multiply negative 20 by 9. Similarly, for the bottom one, I need to multiply 9x by 2, negative 2y by 2, and 64 by 2. So now I've transformed these equations so the x has the same coefficient in both equations. So because the x has the same sign in both equations, it's positive 18 in both equations, I need to subtract the equations. So I just go 18x minus 18x is 0. I'm eliminating the x's, that's why I'm doing it. So negative 81y, subtract negative 4y, two negatives become a plus, I get negative 77y. So negative 180 subtract 128 gives me negative 308. So dividing each side by negative 77, I get y equals 4. So I'm not done. I've only got the y value. To find the x value, I need to substitute back into one of these equations. Doesn't matter which one, I'll again choose the top one. So I would have, if I substitute y equals 4 into this equation, I would have 2x minus 36 equals minus 20. So I'm going to add 36 to both sides and divide each side by 2. So the simultaneous solution to these equations is x equals 8, y equals 4. If I substitute these into both equations, it gives a true statement. All right, let's now look at some worded problems. So for worded problems, define two variables. That means let x equal one of the things you want to find and y the other thing you want to find. Then you need to form two equations and then solve simultaneously. So use elimination, substitution, whichever's easiest. So for example, let's say 2 donuts, 3 cheesecakes cost $17. 3 donuts, 1 cheesecake costs $11.50. Calculate the cost of each item. We use simultaneous equations here because there are two unknowns. So we're going to let x equal one of the unknowns. So I'm just going to let x equal the cost of a donut, and we let y be the other unknown. So that's our first step done. Now we need to take our two bits of information and make two equations. So the first bit of information here tells us that 2 donuts plus 3 cheesecakes gives us $17. And the second bit of information, 3 donuts plus 1 cheesecake is $11.50. So now I've done step 2, I'm just going to go into step 3 and solve simultaneously. So I'm going to use the elimination method here. I want to eliminate the x's or y's, but neither x nor y has the same coefficient in both equations. But if I multiply the second equation by 3, the y's will have the same coefficient. So what I'm going to do is change this equation by multiplying everything by 3. So what I'm going to do is I'm going to multiply 3x by 3. I'm going to multiply y by 3. And I also need to multiply 1150 by 3. So 1150 by 3 is 3450. Now I have that the y's have the same coefficient in both equations. They have the same sign, so I need to subtract. So I'm just going to subtract one equation from the other. I'm actually going to subtract the top from the bottom. I'm going to go 9x minus 2x is 7x. 3y minus 3y is 0. That's why I did this, to eliminate the y's. And so I need to subtract 17 from 3450, which is 1750. So if I divide each side by 7, I get x is 250. So I've just found that a donut costs 250. What would be the cost of a cheesecake? Well, I can substitute into either equation, doesn't matter which one. So I get 2x, 2 times 250 is 5, plus 3y equals 17. Subtract 5 from both sides, divide each side by 3, y is 4. So that means a donut, each donut costs $2.50 and each cheesecake costs $4. So when you're solving these worded problems, make sure you write a worded answer. Make sure at the end you write donut costs $2.50, cheesecake costs $4. All right, let's look at a slightly harder worded problem now. So out of 250 Year 10 students, half of all boys, 2/3 of all girls have a part-time job. 144 students have a part-time job. How many boys, how many girls are in the year group? So again, we want to find two things at the same time. So we let x equal one of the things we want to find. So we want to find the number of boys and we want to find the number of girls. So you let x equal one of the things you want to find, y the other. So we need to get two equations from our two bits of information. First bit of information tells us 250 students in the year group. So number of boys plus number of girls is 250. The second bit of information tells us that half of all boys plus 2/3 of all girls, and that gives us 144 with a part-time job. So now we have our two equations we solve simultaneously. So again, we're going to use the elimination method. Now neither x nor y has the same coefficient in both equations, so we need to multiply one or both equations. So if I multiply this equation here by 6, 2 times 3, I'll make all these whole numbers. So if I multiply this second equation by 6, half times 6 is 3, 2/3 times 6 is 4, and 6 times 144 is 864. So I now want to multiply this top equation by something so x's or y's have the same coefficient. So if I multiply this equation by 3, I get 3x plus 3y is 750. So now I can solve this easily. X's have the same coefficient and same sign. So if I subtract one equation from the other, I'll eliminate the x's. 3x minus 3x is 0. 4y minus 3y is just y. 864 minus 750 is 114. So there are 114 girls in the year, and because there were 250 students all up, there's 136 people. So again, we should write a worded answer to a worded question. So just write something along the lines of there are 136 boys and there are 114 girls. All right, thank you so much for tuning into this video. Best of luck studying for your test, but I know you'll ace it. This has been the luckiest maths teacher in the world. Have a great day.